1.1 Introduction. The understanding of disasters has progressed from a purely technocentric perspective to a social and ecological perspective to unraveling the phenomena associated with disasters. Through most of the 20th century, the theory and practice of disaster management had been dominated by the scientific perspective, whereby disasters were thought of purely as a geological or a climatic problem, the solutions for which lay in engineering and management sciences. In the last 2 decades, there has been a paradigmatic shift in the understanding of disasters in that the human factor, which had been neglected in the earlier approach, is now in focus. The attempt consequently is to inquire into sociological processes that determine or undermine a community's resilience, coping capacity and response to disasters. Understanding of disasters hitherto had been limited to natural hazards. Presently, the term disaster is a more inclusive concept, in that it includes man-made and technological hazards, as also terrorism, which has added a new dimension to its understanding. There are 2 important perceptions on disasters. According to one school of thought, disasters are natural, vengeful acts of nature, an opportunity for man to atone for his sins, wherein death and destruction are inevitable. As per the other perspective, disasters are man-made. An event, whether a product of natural phenomena or human activities, turns out to be a catastrophic disaster if the community or society fails to adequately cope up with it. By systemic understanding, hazard simply acts as a catalyst, in that it brings forth underlying tensions that are always present as potential pressure. Watts, 1983. By the ecological perspective, disasters are totalizing events in which all dimensions of a social structural formation, involving organized human action in the environmental context in which it takes place, is studied. The ecological concept of disaster as a total event involving interaction between environment and nature follows the social perspective on disaster, by which hazards are understood to arise when there is lack of mutual relation between the environment and man. Hoffman and Oliver Smith, 1999. As a society interacts with the environment, with its values and perceptions, and engages in a series of processes over which it has incomplete control and knowledge, for example, development and planning processes, production and distribution of goods, over long periods of time, underlying hazards turn to disasters. Oliver Smith, 1999. 1.2 Theoretical understanding of relevant concepts. For the sake of conceptual clarity, it is desirable to clear the semantic confusion between 3 interrelated terms, viz., hazard, risk, and vulnerability, which are used often in disaster literature. Such an exercise is necessary in view of the fact that a major part of disaster management theory and practice involves scientific precepts and analyses, which requires precision in terminology used. Project planners are required to present an inventory of risks from specific hazards, risks and vulnerability factors that require exactitude in definitions. Hence, hazard is defined as a potential or a latent, dormant cause, which is activated when the right configuration of factors, natural or man-made, are both present themselves. For example, a chemical plant in a populated area is a potential threat to life and property within defined vicinity, hence a hazard. Disaster is the actual occurrence of the apprehended catastrophe. Hence, disaster is any occurrence that causes damage, ecological disruption, loss of human life, deterioration of health and health services, on a scale sufficient to warrant an extraordinary response from outside the affected community or area. World Health Organization, WHO. A hazard technically is not a disaster unless the trigger, natural or man-made, sets it off. The trigger could possibly be weak legislation that failed to regulate the functioning of the facility, as was the case in Bhopal gas tragedy. Hence, a disaster should be defined on the basis of its human consequences, not on the phenomenon, hazard, that caused it. That precisely brings out the difference between disasters and hazards. Earthquakes, floods and cyclones are natural hazards, which cause large-scale loss of life and property. Disaster, when the trigger mechanism, natural or man-made, is activated. Till then, they are simply events in nature. A hazard may or may not lead to an event, or the event in itself may or may not cause damage. Such probabilities are determined by the vulnerability of elements at risk. Vulnerability is the extent to which an element, animate, inanimate, is harmed in the event of a disaster, in other words, is susceptible to a given hazard. Elements are identified as life and property likely to suffer damage in the event of a disaster. Observation and perception of risk involves ascertaining, specifically, such elements at risk. Identification of risk involves inquiring into the specific natural, technological or chemical etc. processes that create the vulnerability of the elements identified for risk analysis. Vulnerability can be natural or man-made. It can be physical, owing to factors such as weak buildings, habitation in hazard-prone areas, or socio-economic, arising due to poverty or marginalization of the weaker sections of society who lack the wherewithal of defending themselves in the event of a disaster. Aforesaid concepts are discussed below in detail. 1.2.1 Hazards and Disasters. The International Secretariat for Disaster Reduction, ISDR, defines a hazard as a potentially damaging physical event, phenomenon or human activity that may cause the loss of life or injury, property damage, social and economic disruption or environmental degradation. Hazards could be natural, geological, hydrometeorological and biological, or induced by human processes, environmental degradation and technological hazards. Hazards can be single, sequential or combined in their origin and effects. Accordingly, hazard analysis entails the identification, study and monitoring of a hazard to determine its potential, origin and characteristics. A fine line separates environmental hazards and environmental resources, as between water out of control, flood hazard, and water under control, reservoir resources. The atmosphere is considered benign when it produces holiday sunshine but hostile when it produces damaging. Lou Smith, 1996. Classification of hazards. Though hazards could be classified on many criteria, some of the general classifications are as follows. S. Gopalakrishnan. Hazards and the disasters they cause are classified as rapid onset or cataclysmic, and long-term or continuing. In a cataclysmic disaster, one large-scale event causes most of the damage and destruction but soon dissipates. Recovery, in the sense of restoration of equilibrium conditions, is relatively faster. In a long-term, continuing disaster, the situation following the event remains constant or may even deteriorate further. Examples of cataclysmic disasters are earthquakes, volcanic eruptions, cyclonic storms, and floods. Examples of continuing natural disasters are droughts, crop failures, environmental degradation, such as deforestation and desertification, etc. The damaged area in a cataclysmic disaster is usually relatively small, while the area affected in a continuing disaster stretches over a wide expanse, spatially and temporally. Long-term impact which affects the past, present, and future of communities. Disasters are also classified as compound and complex. A compound disaster is explained as one crisis leading to other contingencies, such as famines followed by civil strife, mass displacement of people etc. Complex disasters are those that lead to collapse of the political authority or lead to some other complexity where the problems involved, generated are intensely political in nature, such as communal bias in distribution of relief, relocation of communities, compensation, disbursement, etc. Identification of hazards. Identification of hazards involves analysis of scientific data to trace the causal path of events leading to a disaster. For example, identification of chemicals causing water pollution, their source, impact on specific elements, such as human health, etc., inquiring into the nature and characteristics of a hazard with a view to distinguishing the man-made and natural components thereof, for example, floods, which are caused by both natural and man-made factors. Man-made factors include bad land use management policies such as allowing habitation and location of critical facilities in flood-prone areas, which increase the vulnerability of exposed populations, etc. It also entails policy analysis in that the unintended consequences of environment-related legislation has to be examined with a view to framing more environment-friendly legislation in the future. Hazard analysis as the basis of sustainable development policies. For example, desertification is a slow onset disaster. Desertification arises as a result of interaction between a difficult, unreliable and sensitive dry land environment and the human use and occupation of it in an effort to make a living. Following a hazard analysis of the process of desertification, effective strategies can be devised to address the problem. Pollution of water, fire hazard and air arise due to high levels of carbon monoxide, CO, and sulfur dioxide, SO2, in the atmosphere. Other man-made hazards include oil spills, pesticide, etc., which build up in the environment as a result of excessive, repeated application of chemicals by agriculturalists, and flooding and erosions resulting from inappropriate land management practices. Flooding, for example, has been promoted by policies which have allowed building and intensive land use on floodplains and flood-prone regions. 1.3 Understanding risk. Risk is a technical concept which is used by engineering and management specialists to arrive at an estimation of losses in the event of a disaster and the expected probability of its occurrence. Risk is precisely defined by the ISDR as the probability of harmful consequences, or expected losses, deaths, injuries, property, livelihoods, economic activity, disrupted or environment damaged, resulting from interactions between natural or human-induced hazards and vulnerable conditions. Conventionally, the notation expresses risk. Risk equals hazards x vulnerability. Some disciplines also include the concept of exposure to refer particularly to the physical aspects of vulnerability. Risk is different from threat. Threat is a more abstract concept while risk is an expression of perceived threat in specific terms. Threat is a danger that has an extremely low probability of occurrence. For purposes of public policy, threat has to be articulated objectively in terms of risks, the probability of their occurrence and the damages involved in each specific case. For example, apprehension of terrorism was a threat in America. No policy could be devised to meet the threat, since threat had not been articulated as risks for the sake of preventive policy. Vulnerability is understood as system faults or weaknesses, which threat exploits to create the negative impact, known as disaster. Risk management involves minimizing the vulnerabilities so as to reduce the impact of the threat. Risks are both inherent in social systems, are created, or exist due to inherent characteristics in the system. The ecological context is therefore significant in the understanding vulnerabilities of people in different cultures. Risk is sometimes taken to be synonymous with hazard, but risk has an additional implication of the probability of a particular hazard actually occurring. Risks are created due to excessive resource use that leads to serious degradation of the environment. Factors behind such intensified resource use are rapid population growth, market-induced demand, greed of the rich and resource-exploitative public policies such as mining for which rocks are blasted and poisonous substances are released in the environment. Invariable consequences are the disruption of conditions conducive to biophysical processes that ultimately harm the stability and sustainability of mountain environments. Presentation of risk. Risk is a matter of precise quantification. Risk may be expressed in terms of average expected losses from a given hazard to a given element at risk over a specified future time period, for example, as 25,000 lives lost over a 30-year period, or as 75,000 houses experiencing heavy damage or destruction within 25 years, or alternatively, on a probabilistic basis, as a 75% probability of economic losses to property exceeding $50 million in the town of Puerto Nuevo within the next 10 years. The term specific risk is used to refer to risk or loss estimations of either type which are expressed as a proportion of the total. The first two examples might also be expressed as 10% of the total population killed by natural hazards within 30 years, or 50% of houses heavily damaged or destroyed in the next 25 years. Specific risk is also used for financial losses to property, whereas usually refers to the ratio if the cost of repair or reinstatement of the property to the total cost of replacement. Frequently, the shorter term risk is used to refer to what are strictly specific risks. Specific risk gives the average rate of loss or attrition rate. While this is useful for estimating losses over a long period of time, it can give a misleading idea of the nature of risk from natural hazards. Most of the losses actually occur through infrequent single large events, rather than in the form of a slow continuous process of destruction. Coburn, S. Spence, Pomonas, Disaster Management Training Program. 1994. Precise quantification of risk, however, is difficult. At best, a gross estimation of risk is possible, taking, for example, number of deaths and the number of people exposed to a hazard. Such crude estimates give only a limited idea of the likely damage from a hazard for different peoples at different places, or even the probability of its occurrence. For example, the probability of being killed in an earthquake in Iran during any 1 year is obtained from the total number of killed by earthquakes in Iran this century. 120,000 divided by 90 years. This gives an average of 1,300 people killed annually. The population of Iran, currently 55 million, averaged over the past 90 years is less than 30 million, so the average probability of being killed in an earthquake is given as 1 in 23,000.6. SOSS, Disaster Management Training Program, 1994. The assumption seems to be that everybody in Iran is equally at risk, which may not be true. Vulnerabilities of communities and regions within Iran will vary with differential physical, poor quality housing, etc., socio-economic vulnerability. Vulnerability analysis entails assessing the loss of life and property from a particular hazard striking at a particular intensity. For example, X number of people are expected to be killed in property worth Y destroyed if a cyclone strikes with strong winds at 130 km per hour. 1.3.1 Risk Assessment and Evaluation. Risk management has two components: A. Risk assessment, B. Risk evaluation. Risk assessment is understood as the methodology to determine the nature and extent of risk by analyzing potential hazards and evaluating existing conditions of vulnerability that could pose a potential threat or harm to people, property, livelihoods and the environment on which they depend. The process of conducting a risk assessment is based on a review of both the technical features of hazards such as their location, intensity, frequency and probability, and also the analysis of the physical, social, economic, and environmental dimensions of vulnerability and exposure, while taking particular account of the coping capabilities pertinent to the risk scenarios. ISDR. Risk evaluation entails assessment of proposed risk reduction measures from the point of view of cost efficiency. Efficiency is examined by means of cost-benefit comparisons, which imply assessing benefits procured or expected to be procured from a measure against costs likely to be incurred. Assessment has significant administrative implications in that precise understanding of the underlying process of a hazard enables formulation of targeted risk reduction policies. Precise quantification of risk is often difficult in the absence of adequate data and proper analysis techniques. Moreover, certain areas are multi-hazard prone, which poses challenge for risk assessment. Risk reduction policy for such areas requires risk assessments regarding each type of hazard to arrive at an estimation of losses involved. Besides, risks are not amenable to simple quantification in that intangible factors are involved that cannot be easily identified and quantified. Disaster risk is seen as a function of the hazard, exposure and vulnerability, denoted by the mathematical function. Disaster risk equals function, hazard, exposure, vulnerability, where exposure refers to the element which is affected by natural disasters, people and/or property. To reduce disaster risk, it is important to bring down the level of vulnerability and to contain exposure by relocating populations and property away from the hazardous zones. Wisconsin Disaster Management Center. Risk perception. Risk perception is understood as the awareness of risk, which differs in different cultures, societies. Poor countries, with other more pressing problems, do not attach much priority to disaster mitigation. General level of awareness among people regarding the significance of disaster mitigation and preparedness is also quite low. Consequently, there is less interest articulation for policy in this area. On the other hand, risk perception is found to be quite high in the developed world, where much effort has been put into disaster mitigation efforts, though vulnerability is low as compared to developing countries. The role of the media is significant in creating awareness regarding disaster management among people, particularly those at risk. Risk perception depends on certain subjective and objective factors. Risk perception depends on 4 specific factors: exposure, actual quantitative risk level, as articulated through risk assessments; familiarity, personal experience, which makes one alive to the dangers of disasters; dread, horror of the disaster's scale and consequences, which makes policy imminent; preventability, belief in prevention methods, which leads to disaster mitigation policies; risk identification. In a general way, political representatives informally attempt risk assessments by way of informed, subjective judgments as part of daily governance to justify legislations. In foreign policy, the judicial reform, law enforcement, etc., risk assessments are now being conducted in more sophisticated ways, particularly in the field of environmental legislation. Risk has to be empirically ascertained, for which subjective biases arising due to cultural or ideological inclinations need to be kept out of policy judgments. The best example of risk assessment comes from the insurance industry, where insurers have well-defined roles of actuary, underwriter, agent, auditor and adjuster. Each of these is an assessor in somewhat different circumstances or stages of the insuring, reinsuring, adjustment, recovery, and claims payment processes. Hence, risk assessment is a continuous process of articulation, which needs to be undertaken periodically at every stage, phases in said activity, process. Objectivity of the risk assessment depends on the availability of adequate and timely data. Lack of the same has inhibited risk assessments. Risks are divided into systematic and cumulative. K. Smith, 1996. In a systematic risk, the cause and effect phenomenon underlying a disaster is immediate and direct on the global system and results from production-related policies, for example, global warming due to emission of greenhouse gases. In cumulative risks, the relation is indirect, entailing long-term consequences and resulting due to policies in disregard of environment protection lead to accumulation and compounding of risks over time, for example, groundwater depletion, soil depletion. deforestation, etc. The effect of bad policy affects the global system, which suggests that commitment to sustainable development has to be equal in the developing and the developed world. A technical evaluation process is usually undertaken, commonly called hazard assessment, vulnerability analysis, and risk analysis for risk articulation. These are structured, analytical procedures for identifying hazards and estimating the probability of their occurrence and anticipating consequences. These estimations are compared in relation to a standard criterion in order to decide whether or not an action is desirable to reduce the probability of damage or to protect the people, property, or environment. Realistically, it is necessary also to consider to what extent perceived constraints of time and resources might slow down the application of desirable countermeasures. In the case of extreme events and very high level of damage, such as dam break or nuclear power plant accident, the risk is ascertained, estimated by the number of persons affected, victims, injured, etc., and/or the damage in monetary terms that can be expected on an average per year. Risk is also linked to fragility. Fragility denotes the stage of deterioration to a point where damage will occur. Fragility reflects the properties of human ecosystem interactions. It may be defined as the sensitivity of a particular ecosystem to human-induced perturbations and its resilience to such perturbations. 1.4 Understanding vulnerability. Vulnerability gives the extent to which a community is affected by a disaster. It involves the measure of resilience and coping capacity of a community in the face of disasters. Vulnerability is an inclusive concept in that vulnerability of a particular community to a particular type of disaster, flood or earthquake, is a resultant of a number of factors, including physical factors, geographical perspective, social, sociological perspective, and economic factors, income and employment, involving micro and macroeconomic policy, besides institutional or administrative, which are essentially governance-related issues. The process of vulnerability has been evidenced as proceeding along phases such as root causes, dynamic pressures that translate these into active problems, which are a result of a priori decision-making in governance-related matters over time, for example, drought in a dry land area, leading to a famine in the absence of disaster mitigation efforts. Social scientists and climate scientists often mean different things when they use the term vulnerability. Social scientists tend to view vulnerability as representing the set of socio-economic factors that determine people's ability to cope with stress or change. Allen, 2003. Climate scientists often view vulnerability in terms of the likelihood of occurrence and impacts of weather and climate-related events. Related terms are fragility, stability, resilience and sensitivity of a system. These are the constituents of vulnerability. Resilience and coping capacity develop over time as a result of proactive government policies. Stability is the balance, which is disturbed by events such as disasters, hence, restoring balance means correcting distortions. Stability depends on fragility, or the weakness of the system owing to physical characteristics of its ecology. Sensitivity refers to the extent of alteration that is brought about due to exogenous pressures exerted by events such as disasters. Though disaster-related, these are standard sustainable development terminology. Vulnerability identification. Vulnerability identification implies examining the root causes of vulnerability that could lie in technological, physical, or socio-economic conditions and addressing the same through empirical research and policy. Identification of vulnerability is challenging in that complex processes interact in resultant vulnerability of a system or a specific region, peoples. Tackling vulnerability involves both short-term and long-term mitigation measures in that the problem of vulnerability is essentially a problem of development. The solution lies in developmental planning, which addresses the problems of poverty, class and gender discrimination, public health, education and hygiene on a sustained basis. Vulnerability is studied in detail in subsequent units in the course. 1.5 Vulnerability and Risk Assessment. The international community pioneered by the United Nations has attempted to analyze disasters over time and prepare an inventory of causes that lead to them, the extent of damage suffered, what and how mitigation needs to be applied, and where, successfully. Vulnerability assessment is a subset of risk assessment, which analyzes differential vulnerability of communities in differential areas of disaster impact, such as increasing or decreasing degree of hazard proneness. An attempt should be made at redefining disasters in a dynamic and integrated perspective. Integrating socio-cultural. 1.6 Vulnerability factors. As has been rightly pointed out, the study of the vulnerability of human and natural systems to climate change and variability, and of their ability to adapt to changes in climate hazards, is a relatively new field of research that brings together experts from a wide range of fields, including climate science, development studies, disaster management, health, geography, policy development and economics, to name but a few areas. There is need for an integrating framework to bring together these diverse traditions in a coherent yet flexible fashion, allowing researchers to assess vulnerability and the potential for adaptation in a wide variety of different contexts. IPCC, 2001. Both natural and man-made factors contribute to vulnerability. Some of the contributing factors are discussed below. Population displacement. Population displacement is both a cause and a consequence of disaster. There is evidence of positive correlation between poverty and economic inequality and rural to urban migrations, in that more the level of poverty and income inequality, more is the extent of rural to urban migrations. The phenomenon is most observed in poor third world countries where the poor migrate from rural to urban areas in search of livelihoods. The social order remains basically oligopolistic, in that inequality in income and wealth distribution persists over time. System change through soft, democratic options, such as legislation and rhetoric, is not successful as entrenched powers are hard to reconcile to socialist ideas. Result has been corruption and implementation hurdles. More specifically at the implementation change. This largely explains why land reforms and social forestry legislations have not met with expected success. While the size of agricultural holdings has gradually reduced, exploitation of the small and marginal framers at the hands of rich and the resourceful farmers has persisted. Frequent droughts have compounded existing problems. The cumulative effect of such conditions has been mass migration of rural folk to urban metropolitan towns. In the last decade, issues related to natural disasters and development-led population displacement and resettlement and rehabilitation have generated considerable debate. Focus on population displacement, direct and indirect, resulting from 5 natural and human processes wherein data and information is still far from adequate. These processes are natural disasters, urbanization and industrialization, natural resource development, agricultural transformation and infrastructure expansion. There is also a concern that especially vulnerable social groups, including women, ethnic minorities, and landless people, have generally suffered more than others from displacements. On the other hand, population displacement is also a consequence of disasters. In the event of disasters, large-scale displacement of populations from affected areas takes place, which leads to temporary to permanent loss of livelihood for people. Small-scale industries and micro-enterprises are particularly hit. Much work has not been done on providing insurance against disasters to people residing in hazard-prone areas. Though some initiatives have been taken, all disasters have not yet been covered properly and resource mobilization also is far from adequate. Dhar, 2002. Relocation options have also to be carefully weighed so as not to result in unintended consequences that negate the very purpose of the exercise. Unintended consequences as different forms of vulnerability that might be induced because of relocation, for example, loss of livelihood for small businessmen because of increased distance from urban commercial centers. Urbanization. Rural to urban migration has led to unmanageable urbanization and urban congestion that has forced human and physical capital extension in high-risk zones. Consequently, the loss potential of hazards has gone up. Urbanization has brought in its wake growth of informal settlements, unsafe living conditions, disease, class conflict and social capital depletion as some segments have been socially and economically marginalized. Globalization has also contributed in many ways to increasing the vulnerability of the urban poor by creating uncertain employment, though the obvious impact seems to be betterment of life and better opportunities for all. Though urbanization is a worldwide phenomenon, it is more pronounced in the Third World because of the above recounted factors. As per the 1991 census figures, provisional, 217 million out of 844 million persons lived in 4,689 cities and towns in India. In terms of proportion, slightly more than one-fourth of the country's population lived in urban areas. Corresponding figures from the first census of the present century, that is, the 1901 census, indicate that 25.8 million persons, that is, 1/10 of the total population lived in 1,917 cities and towns. It thus shows that while the number and proportion of total population living in cities and towns has more than doubled, urban population itself has increased by more than 8 times during the last 90-year period. Jain, Ghosh, 2005. About 25% of the world's population lives in areas of high risk from natural disasters. Most of these people are in poor regions, where vulnerability arises from poverty, discrimination and lack of democratic functioning hampers the development process. The poorest people often have little choice but to live in unsafe settings, whether it is urban shanties or degraded rural environments. In terms of loss of life and relative economic impact, disasters hit hardest where poverty-stricken people are concentrated. In less developed countries, rural inhabitants outnumber people in the urban areas. Even then, now there are more urban dwellers in the Third World than in Europe, North America and Japan combined. Metropolitan cities are growing at a faster rate. It is estimated that in urban squatter settlements, population densities may reach as high as 10 times of present level. Many buildings are erected on steep slopes or flood-prone land, exposed to strong winds and landslides without suitable material or construction skills. In highly populated rural areas, population density can exceed 1,000 per square kilometer and life is a recurrent struggle to secure cultivable land. Many people are landless and disadvantaged by land tenure systems, which deny them access to the means to support themselves. Migration also has significant cultural impact, besides the more obvious, physical dislocation of populations in that mass migrations introduce communities to alien cultural practices, which disturb the cultural homogeneity of the community. In extreme conditions they cause civil strife. Different building practices and construction technologies may be introduced, which might be unsuited to the requirements, cultural ethos and practices of those particular area inhabitants. Besides, administrative and political problems are caused due to the influx of refugees, which disturbs the political and social matrix of the region, like the influx of Bangladeshi refugees in India, following the 1971 war. Epidemics and congestion are other administrative problems caused due to mass influx of refugees. Gender. Vulnerability due to gender is a result of accretion of unfair social practices over time. which has caused disempowerment of women in social, economic, and political spheres. Gender inequality in social, economic, and political spheres has resulted in vast differences between men and women in emergency situations, concerning matters such as household decisions about use of relief assets, voluntary relief and recovery work, access to evacuation shelter and relief goods, and employment in disaster planning, relief and recovery programs, among other areas of concern in disaster relief. Disaster mitigation as also response policy, particularly concerning control over relief resources, have to factor this component in decision making with a view to making it more equitable and on the whole, more effective. Economic factors. Positive correlation has been evidenced between poverty, disasters, and environmental degradation. Relative vulnerability of people is comparatively much higher in third world countries than in the developed world. As per United Nations estimates, although least developed countries show less physical exposure to hazards, 11%, they account for far greater number of casualties, 53%. On the other side, the most developed countries represent more, 15%, physical exposure to hazards and account for significantly less, 1.8%, victims. The inference drawn is that the magnitude of disaster suffered is directly correlated to the level of development, which explains largely the fact of the third world accounting for significantly more losses than the developed countries. This difference is shown by a list of disaster events and fatalities over 1960 to 81. Japan suffered 43 earthquakes and other disasters and lost 2,700 people, that means 63 deaths per disaster. Peru suffered 31 disasters with 91,000 dead, a vast majority lost in the single event of the 1970 earthquake. The world economy functions and works against the poor who have little opportunity to process and market what they produce and are largely dependent on the imports from the industrialized nations for manufactured goods, which are quite often unstable. The poor regions have little opportunity to process and market what they produce and are dependent on the import from the industrialized nations of manufactured goods, which are often highly priced, are tied to aid packages. The progressive hardship for the small-scale farmer, combined with a foreign debt burden that may be many times the normal annual export earnings, takes resources away from long-term development in a process that has been described as a transfusion of blood from the sick to the healthy. The cycle is reinforced when natural disaster destroys local products and undermines incentives for investment. Major disasters, such as the droughts, disrupt and destroy local economies and bring about shortages in neighboring regions, resulting in innumerable international refugees, and stimulate aid programs to the extent that the consequences of environmental hazards are truly global. Poverty situation increases vulnerability to disasters and contributes in enabling poverty. In order to facilitate sustainable development, it is essential to eliminate this vicious circle. Sustainable development, with emphasis on the long-term and intergenerational aspects, enables us to face challenges. Compatibility between economic growth and sustainable development demands a method to measure the kind of growth that encompasses all important aspects pertaining to quality of life, such as human exposure to risk situations and lifestyles. While all countries may be confronted with natural hazards, the poorer developing countries, in particular, are disproportionately vulnerable to hazards. Disasters can bring poor communities to even greater poverty, as households may be forced into increased debt to rebuild homes and meet basic needs. There is also the paradox that the economic aid that may flow to a country for devastation by a natural disaster will be recorded as an increase in GDP, thus hiding the real economic situation in the recovery phase. Effects of disasters on poorer developing nations are long-lasting and cause excessive disruption in the GDP, United Nations, 2004. The effects are more severe than in developed countries, often depleting scarce financial resources and diverting important funds towards post-disaster relief. Poor nations have been known to sanction activities like forest clearance for commercial activities and export of hardwood, since sizable numbers of their population depend on such activities for livelihood. Unsustainable agricultural practices followed in developing countries, particularly by small and marginal farmers, harm the environment. The poor are forced to live in high-risk zones that increase their vulnerability. IGNOU, 1999. Poverty is not a single-dimensional economic concept. Poverty affects the positioning of the affected segment in relation to the haves, which is a situation of political disempowerment, economic deprivation and social marginalization. As has been recently reported, relief and rehabilitation assistance does not reach the backward sections of society adequately. During the recent tsunami, it was found that society in coastal areas comprises generally farmers and fishermen who have strict social hierarchies. This differentiation was reflected in relative access of communities to relief provisions. Affirmative state action as per constitutional provisions, Article 14, 15(1), 15, 4, and Article 21, right to life, would have be enforced to ameliorate the unequitous situation. Directive principles of state policy, namely Article 39, right to livelihood, 41, public assistance in cases of undeserved want, and 47, raise the level of nutrition, reaffirm the obligation of the state to protect livelihoods of those discriminated against. It is proposed that risk reduction strategies targeting poverty should involve local institutions more meaningfully and focus on providing alternate livelihood options to the poor and providing safe working environment by reducing occupational hazards which increase the vulnerability of the poor to hazardous events. IGNOU, 1999. Geographical factors. Global warming threatens to disrupt agriculture in developing countries, though most greenhouse gas emission has taken place from the developed world. Global warming has particularly increased the vulnerability of coastal areas, especially small island development states, SIDS, in that sea level rise will threaten the fragile ecosystem of these regions, raising the frequency and intensity of natural hazards like tsunamis, cyclones, floods and storm surges. Coastal zones, wetlands and coral reefs are likely to be harmed, which act as natural buffers against hazards like cyclones. The magnitude of disasters is also likely to be greater because of the increased pace of infrastructure development that has taken place in these regions in the last few years, owing to population pressure and growing attractiveness of these regions from the point of view of tourism. UNDP, 2002. SIDS are subject to excessively high impacts from natural hazards and disasters. As has been noted, they are particularly vulnerable to tsunamis, tropical cyclones, which can in one go negate years of development effort. Numerous small island developing states are facing water scarcity, drought, sea level rise and natural disasters have a profound impact on fragile freshwater lenses in SIDS. Water availability is also climate sensitive. Countries such as the Bahamas that traditionally depended almost totally on groundwater, now also have to use desalination, which contributes to their vulnerability. In addition, the economies of many SIDS are dominated by agriculture and tourism. Agriculture can cause degradation of water quality by agrochemicals as well as harm the coral reefs. Tourist hotels use excessive quantities of water, and wastewater discharges from towns and hotels are damaging fragile coastal and marine ecosystems on which these islands rely. Herman et al. Livestock vulnerability. Livestock at times is the poor man's only asset. Unlike other forms of property, livestock loss is irreplaceable. The contingent issue here is immediate provision of alternate occupation, which is the most difficult part of rehabilitation. Shortage of food affects livestock before it starts to affect human beings. Malnutrition and disease reduce their productive capacity, which results in reduced income for the farmer. Diseases among livestock also spread during disasters. These still remain less considered aspects of disaster management. Insurance is the best option, but it still needs to be duly considered. In India, vulnerability factors would be discussed in detail in subsequent units. 1.7 Conclusion. Shift of emphasis from disaster response to risk reduction has opened up areas of exploratory research in the subject of disaster management. Vulnerability analysis seeks to preempt disasters by ensuring timely preparedness on the part of people and institutions and government agencies involved. Disaster management is an imminent administrative task for reduction of disasters through prevention, preparedness, mitigation and response. There has been a paradigmatic shift of emphasis in the last decade from disaster relief and rehabilitation to prevention and mitigation strategies. Post-occurrence treatment of disasters has proved an insufficient measure for proper protection of lives and property. There is also an emphasis on mainstreaming disaster management in everyday governance by treating it as integral to policy formation and implementation processes. Disaster management, as a growing arena of state action, raises questions related to new public management and public choice paradigms. Though civil society, typified by non-government organizations, is set to take an active part in restorative and rehabilitation measures, it is the government agency that is expected to function as the prime mover, besides being the regulator and the facilitator. It is pertinent to refer, in this context, to the social contract theory of the origin of state, which is widely accepted as a secular explanation of the evolution of the state. According to social contract stipulates, people impart authority to a state, abdicating a measure of their personal liberty and delegating the same to the state, in return for protection of life, liberty and property. By this theory, people are the sovereign entity and state, the instrumentality to carry out the delegated responsibility. The emerging arena of disaster management as an integral aspect of development planning, policy formulation and implementation is of particular significance in the wake of the new public management contention of expected rollback of the state and ascendant civil society and private corporate sector. Despite assumptions to the contrary, new vistas continue to emerge for state action, intervention. The basic question remains, can the state roll back? Any answer would only be diffident in view of the fact that despite public choice assertions and new public management propaganda of the economy and efficiency of alternate service delivery mechanisms, the government remains the major player. It is the government that is called upon to bear the major share of responsibility and accountability for protection of life, liberty and property of its citizens. It is the government that is looked upon for responsibility and accountability in almost every regard, more so in emergencies. Thank you for watching. We will see you in the next video with the next chapter.